Hey guys, welcome to the chemistry video, and today we are going to try to understand what is molarity. So let's get right into it. So what is molarity? It's basically a measure of quantity. Exactly meaning how much. How much of a solute is there in a standard quantity of solution. Now, how do you go on defining molarity in this terms? So you say molarity stands for moles of a solute in the liter of a solution. Very important. The volume should be of the solution, not the solvent. What is moles? Just in case it's a little bit rusty at your end, so you should know moles is given weight. How do you calculate mole? What is the amount of solute? What is the weight of the solute that you have taken divided by the molecular weight of any substance? Let's take an example. Let's say you are dissolving 23 grams of sodium hydroxide in 1 liter of water, right? So what should be the molarity here? Let's first find out the weight of sodium hydroxide, right? So sodium, that's 23, oxygen, that's 16, hydrogen is 1, right? So that comes out to be 23 plus 16 plus 1, that goes to be 40. Now, what was the definition? Moles per liter. So, my molarity in this case would be given weight. Remember, given weight upon molecular weight is 23. Molecular weight we just calculated to be 40, and this is all dissolved in 1 liter. Now, if you quickly do the maths, you will get here to be 0.575 molar, or you can simply write it as 5.7 into 10 to the power minus 1 molar. So that is our molarity of a solution when we dissolve 23 grams of sodium hydroxide. Let's solve one more problem so that we get a hang of it. Now, you must add 0.184 gram of sodium hydroxide, that is NaOH. Again, I think you remember we just calculated the molecular weight. So let me write it right here for 40 grams in an aqueous solution. How many ml of 0.150 molar solution should be added? So you know molarity is equal to moles per liter. So I'm just writing it like this, moles per liter of the solution. Very important, solution. Now, what do we know? We know the molarity. So let's fill it right there, 0.150. Do we know the moles? No, but do we do know that we must take what is moles? Given weight upon molecular weight and volume of solution, right? So do we have the given weight? Yes, we do. We must add how much? 0.184 grams. Do we have the molecular weight? Yes, we do have. That is 40 grams. What do we not have? We do not have the volume. We do not have the volume of solution which we must take in order to find out. So let's switch sides. So this implies if you take this guy little here, so volume comes to be 0.184 upon 0.150 upon 40. Now you just need to do simple maths. That comes out to be 0.0 0.03066. So if you just round them off and write it in significant figures, so you have 3 approximately 0.0 rounding off, you get 7 into 10 to the power minus 2 liters. Now remember, this is liters, right? The question is asking you about ml. Now why it's liters? Because the standard formula uses the SI unit, that is liters. Now 1 liter has 1000 ml, so you can simply 30.7 ml. That is how you calculate. So I hope this makes sense for you. Now I want you to try a problem of your own, and we'll discuss this in the next video. You're provided with a solution that is 4.8 molar NH3. How many milliliters of this solution should you take so that you have 100 ml of 1 molar NH3 when diluted? You should know let me know the answer in the comments below, and we'll do another video and talk more about it. I should give you a hint. This has to do with dilution, right? Thank you.
We hope you like this video. Press subscribe, thumbs up, and stay geekly.